Good day, everyone. Welcome back again to our series of AS and A-Level Computer Science 9618 lecture series. For our discussion, we are going to discuss about number conversion or the different number systems that is actually being used in computer systems. We're going to start with some key discussions here. We have binary to decimal conversion, and of course, the next would be decimal to binary conversion. Let me start with decimal to binary conversion. Let us say we have here a number that we are going to convert into its equivalent binary. Then we have here 75. Take note that there are some instances that the decimal is actually being replaced now. Not actually being replaced, but there are some textbooks now that using now what we call denary. Okay, so converting the decimal number 75 to its equivalent binary, or simply just the same saying that converting the denary number 75 to its equivalent binary. So one of the famous method that I usually use is using what we call the weighted method. And as you can see here, we have here the step 1. Step 1 is write 1 to 8 to 1 numbers. What does it mean? If you notice, you start here from the rightmost, 1, 2, 4, 8, 16, 32, 64, and 1 to 8. Definitely that is the weight of each, what you call this one, of each value when you're going to map it with the different positions of the binary number. So from here, starting on the right hand side, write down 1, 2, 4, 8, etc., doubling each time until you reach 1 to 8. So for example, we have your 1, then 1, then 2, 2 times 2, and then that is equivalent to 4 times 2 times 2 times 2, and so on. So these are considered as powers of 12 multiples of 2. Remember, smallest number at the right hand side. Okay, so 1, 2, 4, 8, 16, 32, 64, 1 to 8 is the last number. Not actually the last number, you can extend. So 1 to 8 times 2, that's equivalent to 256. So take note, yeah, you're just going to write all of these numbers because it's considered as a weighted method. And you will soon discover why it is considered as a weighted method. Each digit of a binary number actually has a weight. Okay, step number 2. Your step number 2 now is cross out the unused numbers, keeping only the numbers that you need to add up to your decimal number. Cross out all other numbers. What does it mean? We have here the value 75. I'm actually writing it now. And how can you get the value 75 from all of these numbers, from the numbers 1, 2, 4, 8, 16, 32, 64, and 1 to 8? Of course, you cannot use 1 to 8 because 128 is greater than 75. So you need to move to the next number, which is 64. 64 is less than 75. So definitely, you can use 64 because it's less than 75. Take note, it is what number combinations here from these numbers 1, 2, 4, 8, 16, 32, and 64 are you going to use to get the value 75? As simple as that. Okay, it's just a simple addition operation. It's just a simple addition. So since 64 okay, is actually less than 75, I will use 64. Now, you're just going to, you're just going to subtract now 75 from 64. So if you're going to get the value that is subtract 64 from 75, okay, 64 minus 75 is actually equivalent to 11. Okay, 64, you subtract 64 from 75, we get 11. Now, that is already the value that you're going to use to, how are you going to get the value 11 from the remaining numbers? Of course, 32, you cannot use that one because 32 is greater than 11. 16 is greater than 11. So you notice the values that are larger or I mean the values that are larger than the existing value that you're going to to get the result from the values here, okay, will be crossed out. Okay, keeping, okay, as mentioned here, keeping only the numbers that you need to add up to your decimal number. Cross out all other numbers. So that's 11. How can you get 11 now from the remaining numbers, which is 32, 16, 8, 4, 2, and 1? Of course, you cannot use 32 and 16 anymore. So what is left is 1, 2, 4, 8. How can you get 1, 2, 4, 8? It's very easy. How can you get 11 from the values 1, 2, 4, 8? So definitely that is just equivalent to 8 plus 2, that is 10, and then plus 1, that is equivalent to 11. So you notice now 64, those numbers that was not crossed out, meaning that was not used. Remember, when I remember the keyword that I'm using, used and unused. If you use it, okay, usually that is considered as logic 1, or it's considered as on. You are using it, it's true. If it is unused, of course, you're not using it. It's 0. It's null. Okay? So that's one. One reason why 64 was placed here. 64 plus 8 plus 2 plus 1 is now equivalent to 75. Now, how are we going to get the binary number? This is now considered as, considered as the very wonderful and at the same time a very good and interesting part of number systems. Step 3 now is write the ones or zeros. Under each number, write 1 if there is a number, and 0 if you cross out the number. Meaning to say, those numbers that was crossed out here, 32, 16, and 4, of course you did not use it. It is crossed out. It is null. That is equivalent to 0. That's why it's considered as weighted method. And those numbers, okay, that you have been used to get the number 75, that is actually your, let me use a green color there, 64, we have there 8, we have there 2, and we have 1. It's just a simple addition. Okay, so 64 plus 8 plus 2 plus 1. It depends on the problem. Since there was no consideration in how many bits the numbers is going to be represented, 2, 4, 6, 8, usually 8-bit or it could be 16-bit. Okay, it depends. Now, in our example, the binary number now is equivalent to, take note, 0, 1, 0, 0, 1, 0, 1, 1. Okay, this is now the binary equivalent of the decimal number 75. Now, how are we going to verify? So it's already, it's very significant already that 64 plus 8 plus 2 plus 1 is equivalent to 75. So those numbers that you use to come up with 75 are actually the numbers that you're going to put or mark as 1 in this method, weighted method, or having the weight 1, 2, 4, 8, 16, 32, 64, and 1 to 8. So the least significant bit here, the LSB, is this one. And this is your most significant bit considered on the left side, okay, the 1 to 8. So how to verify? Let me use one converter. Actually, this is also very useful. So going here in the rapid tables, okay, and since your conversion is from decimal to binary, then we are just going to enter there, place 75, as you can see. Then I'm going to click there, convert. You notice, since this is a binary number already, 100, 1011, 1, 2, 3, 4, 5, 6, 7. 7 bits only that was given, because if you notice here, okay, it will be omitted. It can be omitted, the zeros here, but if the problem requires you to have what we call the 8-bit, okay, 8-bit binary equivalent, then this 0 is very significant. Okay, so that's correct already, and that would end up my decimal to binary conversion. Next would be decimal to, so reverting it back from decimal to binary.